What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 7, Section 2, Right Triangle Trigonometry. Let's do it. So for this one, it says label the adjacent, opposite, and hypotenuse for this angle. So adjacent to this is the side next to it, but it's not the side that is the hypotenuse, right? It's also next to the hypotenuse, so it's the adjacent leg. Now, the opposite side is, of course, the side opposite the angle, straight across, so that makes sense. Last but not least, the hypotenuse, that's always opposite the 90-degree angle. That's the big side, so here is the hypotenuse. That's how you do it. Done. So this asks the tangent of an angle compares which side of the right triangle. And we can remember this with this nice acronym, SOHCAHTOA. And when we look at a triangle and we've got, hey, here's our angle theta, and this is the right angle. If we're talking about tangent, it's this right here. And this is a nice way to remember it. Tangent is opposite, that's the O, so it's the opposite side, over the adjacent side. So let's say this is the adjacent side. So if I call this X and I call this Y, tangent of that theta would equal X over Y. That's how you do it. Done. So when talking about cofunction identity between sine and cosine, what it's basically saying is, if I have an angle here, let's call it theta, and let's call this one B in here, right? It says that sine of a certain angle, let's say sine of theta, and we're going to label all the sides, right? We're going to label it X, Y, and the hypotenuse is Z. So sine of theta is opposite over hypotenuse. So that is Y over Z equals cosine of the complement of this angle. And cosine of the complement of this angle is B. So how do I know that? Because all these angles add up to 180, and since that adds up to 90, that means these two must add up to 90, aka they're complementary. And then if I look at what is cosine of B, that is adjacent over hypotenuse, and side Y is adjacent to B. So cosine of B is Y over Z, and this is what it shows you, is that sine of an angle is equal to cosine of the complement of that angle. They're both the same, and that's the cofunction identity. So this one, using the cofunction identity, cosine of pi over 3 is equal to sine of the complement of this angle. Now, since we're in radians, we're really asking what plus this is going to give us pi halves. That's 90 degrees, right? And that's actually going to be pi 6. And I can show that these two are complements because pi thirds plus pi 6, and again, I'm going to multiply by 2 and by 2 to get common denominators, is going to be 2 pi 6 plus 1 pi 6, which is 3 pi 6, which reduces to pi halves. And once again, pi halves is 90 degrees in radians, so it makes sense then that this is the complement, so it's pi 6, boom, done. So for this one, tangent of an angle equals cotangent of the complement of this angle. And what's the complement of pi fourths? It's also pi fourths. Why is that? Because pi fourths plus pi fourths equals pi halves. And that's the same as 90 degrees, right? But just in radians. And that's the definition of complementary angles. So pi fourths is the answer. Done. So for this question, we know that C is the hypotenuse, and then we've got A and we've got B. And likewise, angle B is here opposite little b, angle A is here, and then angle C is here. So now we know that A is 20, and we know that sine of B is 1/2. So what is sine of B? Sine of B is opposite over hypotenuse. So since sine of B is also opposite over hypotenuse, which is B over C, we also know that this equals 1/2. So I basically know that B over C equals 1 over 2, which means that there's a relationship between B and C. B, if it's X, if it's 1X, C would be 2X. So now we can use this via Pythagorean's theorem to solve for B and C. So now using Pythagorean's theorem, I can say A, which is 20 squared, plus B, which I'll call X, is X squared, equals C squared, which is 2X squared. And then 2X squared is 4X squared, right? I'm squaring both, equal to X squared plus 20 squared, which is 400. Now I'm going to subtract X squared from both sides. I get 400 equals 3X squared. Then I'm going to divide both sides by 3. And X squared equals 400 over 3. Last but not least, I'm going to take the square root of both sides. And X equals square root of 400 is 20, and the square root of 3 is 3. Just to rationalize this, by the way, we could say plus or minus, but this is length, so we don't have to worry about a negative. So then I'm going to rationalize the denominator by multiplying by rad 3 and over rad 3. So then I get X equals 20 rad 3 over 3. And again, X is B. So that really means B equals 20 rad 3 over 3. And now when we get to C, C is just double this, right? So C is 2 times that, which is 40 rad 3 over 3. So there are your two answers. Boom, done. So for this one, we've got our triangle set up this way, and I know that B equals 100, and then I also know that tangent of A is 100. And what is tangent of A? Again, going back to our SOHCAHTOA, tangent of A is opposite over adjacent. So opposite over adjacent. So tangent of A is A over B, which we know B is 100, and this is equal to, it's saying tangent of A is equal to 100. So now we have a nice little equation. A over 100 equals 100. So to solve for A, multiply both sides by 100, and we get A equals 10,000. Now to get C, we're going to use Pythagorean's theorem. So we have A, which is 10,000 squared, plus B, which is 100 squared, equals C squared. So 10,000 squared, that's huge. So that's 100 million. 100 squared is 10,000, and this equals C squared. You add it together, we get 100 million and 10,000 equals C squared. And then we're going to take the square root of both sides. And when you plug it into a calculator, you get approximately 10,000.5 rounded to the nearest tenth. So there's your value for C. Here's your value for A. Done. So for this one, there's a couple ways to approach it. The first thing is, if I know that this angle is 60, I know that this angle here is 30. And then we can use what we know about special right triangles to solve this, or you can use trigonometry, right? You can say like sine of 60 equals 5 over C and solve for it that way using a calculator. But I'm going to actually use special right triangles and solve this without a calculator. So when I know the side opposite 60 degrees, to get the side opposite 30, I have to divide by radical 3, because normally when I go from the little side opposite 30 to the medium leg opposite 60, I multiply by rad 3. So I'm just doing the opposite. And then to rationalize this, multiply by rad 3 over rad 3, and we get 5 rad 3 over 3, and that's our value for B. Okay, and then to get C, we double the little side, the side that is opposite the 30 degrees. So if we double that, C equals 10 rad 3 over 3. So there are your two solutions. Boom, done. So for this one, we want sine of A, and going back to SOHCAHTOA, okay, sine of A is opposite over hypotenuse. So what's opposite A? That is 10. And what's the hypotenuse? Actually, we don't know what the hypotenuse is. So we can calculate that using Pythagorean's theorem. So what I have is A, which is 4, so 4 squared, plus B, which is 10, so that's 10 squared equals C squared. So that's 16 plus 100, that's 116 equals C squared. Take the square root of both sides, and we get C equals, and then 116 is the same as 4 times 29. You can take the square root of 4, which is 2. So then it becomes 2 rad 29. So that's the hypotenuse. And so this is opposite over hypotenuse 2 rad 29. Now we can simplify. So first I'll divide both by 2. I get 5 and 1. And then let's rationalize the denominator. We don't want the radical in there, so I'll multiply by rad 29 over rad 29. The reason why is because rad 29 times itself is just a nice 29. And then on top we have 5 rad 29. So there's your answer, done. So for tangent of A, if we remember SOHCAHTOA, tangent is opposite over adjacent. So opposite A is 10. Adjacent to A is this one. It's the adjacent leg, which is 4. So it's just 10 over 4, which reduces to 5 over 2. Boom, done. So for this one, we've got secant. So what is secant? Well, sine and cosecant are what are called inverses, right? So whatever sine of an angle is, cosecant is the reciprocal of that. Likewise, cosine and secant are reciprocals. So when we think about secant of A, we should be thinking about what is cosine of A, okay? And then going back to our nice SOHCAHTOA, we know that cosine is adjacent over hypotenuse. So if it's A, it's adjacent, the adjacent leg over the hypotenuse. So what is the hypotenuse? Using Pythagorean's theorem, it's 4 squared plus 10 squared, right? A squared plus B squared equals C squared. That's 116 equals C squared. And then we take the square root. 116 is really 4 times 29. So as you simplify, you take the square root of 4. and you get 2 rad 29. So there's your hypotenuse. So again, cosine is adjacent over hypotenuse, so 4 over this. But since we're doing secant, which is the reciprocal of cosine, it's the other way around. It's hypotenuse over adjacent. So it's 2 rad 29 over 4, and these can be divided by 2. So then it's just rad 29 over 2. That's how you do it. Done. So for this one, we're meant to find sine of A, which is opposite over hypotenuse. But the thing is, I don't know what the hypotenuse is, so we need to solve for this first. And I'm going to use Pythagorean's theorem to do so. So I'm going to take 8 squared, which is that leg, plus 10 squared, which is that leg, equals c squared. So this becomes 164 equals c squared. Now we're going to take the square root and the square root of 164. Let's find that now. So this is 164 is really 4 times 41. And that's nice because 4 is a perfect square root. I can take the square root of 4 and it is 2, and then the 41 stays trapped inside. So now I get a hypotenuse. So now I got sine of A, which is opposite over hypotenuse. So it's 10 over 2 rad 41. Divide top and bottom by 2, and I get 5 over rad 41. Last but not least, I need to rationalize this denominator, so I'm going to multiply the radical by itself. And I can do it by 41 over 41 because, again, that's 1, right? Anything over itself is 1. I can multiply by 1. It doesn't change the value. So then on top, I have 5 rad 41 over rad 41 times itself, which a radical times itself always just becomes the number without the radical. It's free. So now we have 5 rad 41 over 41. Boom, done. So for this one, we're taking tangent of A, and with SOHCAHTOA, tangent is opposite over adjacent. So opposite is 10 over the adjacent leg, which is 8. 10 over 8 reduces to 5 over 4. That's how you do it. Done. So for this one, we're taking secant. And if you recall, secant is actually related to cosine, meaning whatever cosine of A is, secant is that reciprocal function. It's going to give you a reciprocal value. So first, let's find what cosine of A is. And cosine of A is adjacent over hypotenuse. So we don't know the hypotenuse. We have to solve for it. Now, we did this in previous questions, but I'm going to show you how to do it again. We use Pythagorean's theorem. Little leg squared plus medium leg squared equals c squared. This gives us 164 equals c squared. And then as you take the square root of both sides, you end up getting square root of 164, which simplifies to 2 rad 41. And if you're wondering how I did that, 164 is really 4 times 41, right? That gives you 164. Square root of 4 is 2, so that comes outside. The 41's trapped inside. So that's how we get the hypotenuse. Now, cosine, as I mentioned, is adjacent over hypotenuse. But secant, since it's the reciprocal, we're taking hypotenuse over adjacent. So it's 2 rad 41 over 8. Divide top and bottom by 2. And then we get rad 41 over 4. That's how you do it. Done. So here we're meant to solve for B and C. And we can use trigonometry, but we actually don't need it here because they gave us this angle. And that means this is a nice special right triangle. And with the special right triangles, in particular 30, 60, 90, I know that since 7 is the little leg, the big leg is just the little leg times rad 3. So B is equal to 7 rad 3. And then C, the hypotenuse, is double the little leg. So 2 times 7 is 14. So those are the two sides. Boom, done. So for this one, it's again a nice special right triangle where this is 45 degrees as well. And the great thing about a 45, 45, 90 special right triangle is that the hypotenuse is always the legs times radical 2. Well, look at that nice radical 2 out there. That means to get back to the legs from the hypotenuse, I divide by rad 2. So it's basically just 15 for both of these sides. So that's how you do it. Done. So for this one, we're going to use a little trigonometry to solve for B and C, and we're going to use a calculator to help us out. So first, I'm going to write out SOHCAHTOA to guide us a little bit in terms of how to use these functions. So let's start with sine of 35. So what does sine of 35 equal? It equals opposite over hypotenuse. So it equals 7 over C. So this is pretty cool because this gives us an equation that we can use to now solve for C. So first I'm going to isolate by multiplying both sides by C, and then I get C sine 35 equals 7. And then I'm going to divide by sine of 35, okay? I'm going to do that to both sides. That's going to cancel out. So here's what I have for C. Let's plug this into Desmos and get our approximation. So here we get 12.2041 So that's our value for C. Now let's solve for B. Now again, we've got C, we've got A, so we could actually use Pythagorean's theorem, but let's use trig again. Now instead of taking sine, I am going to take tangent of 35, okay? And the reason why I'm choosing tangent is because tangent is opposite, which we already have, and it's a nice whole number. So opposite over adjacent, and adjacent happens to be B, which we still need to solve for. Again, I'm going to multiply both sides by B first, and then once I have this equation, I'm going to divide by tangent of 35, like so, and we're going to plug this into the calculator. So here we get 9.9970. So B equals 9.9970. So those are your answers. Done. So for this one, we have the hypotenuse, and now we need to solve for A and B. So again, I'm going to put up SOHCAHTOA, and I'm going to start by taking sine of 10 degrees. And what does sine equal? Sine equals opposite over hypotenuse. So we've got A over 12. Now to solve for A, I'm going to multiply both sides by 12. And now to get the approximation, we're going to plug it into the calculator. So here we get 2.0838, and that's our value for A. Now to get B, well, I have a couple different options, but why don't I just go with cosine of 10? And I'm going to show you why. Again, cosine is adjacent over hypotenuse. So that uses B, which is what we want, and over the hypotenuse, which we know. So that's a really nice function. So now we have that nice whole number to isolate. We're going to multiply both sides by 12. And then to get this approximate value, we're going to plug it into the calculator. So here we get 11.8177. So B equals 11.8177. That's how you do it. Done. So for this one, they didn't give us a triangle, so we're going to draw it out here. So I got 15 degrees for B. I know that's 90. And I do know that A and B are complements. So just for fun, I could put 75 in here. And then I know that little b, which is going to be opposite big B, is 15. Okay, now let's solve for the hypotenuse as well as this leg here, which will be A. So first, what I'm going to do is I'm actually going to use tangent as my first function. The reason why is that's going to allow me to solve for A. So I'm going to take, and I'm going to do this a little strategically. I could do 15 or 75, right? I'm going to choose 75 because it's going to save me one step, and I'm going to show you why. So if I take tangent of 75, I get opposite, which is A, over the adjacent side, which is 15. And that's great because now to solve for A, I just multiply both sides by 15. I don't have to do any other steps. So you see, it's a little better than if the variable were on the denominator. Then I'd have to multiply and then divide. It's one more step. It's not a big deal, but just to be most efficient as possible. So now let's plug this into Desmos, and we get 55.9808. So that's our value for A. Now, when we want to solve for the hypotenuse, which is C, I'm actually going to use 15. Again, I could use 75, but I'm going to use 15, and I'm going to use sine because I can take sine of 15, which is opposite over hypotenuse. So sine of 15 equals opposite, which is 15 over hypotenuse, which is C. Now to solve for C, we have to multiply both sides by C first, and then divide by sine of 15 second. So we're going to plug this into Desmos and see what 15 over sine of 15 gives us. And that's 57.95555. So 57.9555, and that's your answer. Boom, done. So for this one, they didn't give us a triangle, so I'm drawing one out, and I see C, which is the hypotenuse, is 50. I see this angle B is 21. So we need to solve for A, and we need to solve for B, which are the two legs. All right, let's write up SOHCAHTOA again. And I'm going to start by trying to solve for B. So I'm going to say sine of 21 equals opposite, which is B, over hypotenuse, which is 50. And then now to solve for B, we multiply both sides by 50, and I get B equals 50 sine 21. And now let's plug it into Desmos. So we get 17.9184. So there's our value for B. And now let's solve for A. And for A, what I'm going to do is I'm going to use 21 again, but now I'm going to take cosine of 21 because that's going to give me adjacent over hypotenuse. So we got A over 50 hypotenuse. So then I'm going to multiply the 50 over here, and I've got A equals 50 cosine of 21. Let's plug it into the calculator. So we get 46.6790. So there's your value for A. That's how you do it. Done. So for this one, they didn't give us a triangle, so I drew one out saying that A is 78. C is, of course, 90. Just for fun, B can be 12. Not that it matters so much, we don't need it, but these two are going to be complementary with this one being 90. And little b, which is this side, is 3.5. Okay, so now we need to solve for A and, of course, C, which is the hypotenuse. So I'm going to write SOHCAHTOA, and I'm going to start actually with tangent, because what is tangent? And we're going to take tangent of 12. What is tangent? Tangent is equal to opposite over adjacent. So we got opposite, which is 3.5 over adjacent, which is adjacent to 12, which is a. And now we can solve. We're going to first multiply both sides by a. So I get a tangent of 12 equals 3.5. Then we're going to divide both sides by tangent of 12 like so. And we're going to plug it into Desmos. And for a, we get 16.4662. So there's our a value. And now to get c, I'm actually going to use sine of 12. So sine of 12 equals opposite over hypotenuse, opposite over hypotenuse. So we get 3.5 over c. Multiply both sides by c. C sine 12 equals 3.5. Then divide by sine 12. So c equals 3.5 over sine of 12. Let's plug it into Desmos. And we get 16.8341 when we round up. So c equals 16.8341. That's how you do it. Boom, done. So this one says find x, and we're going to use trigonometry to do so. So I'm going to write SOHCAHTOA up here. Now, what I would love to do is be able to find this segment here and then this segment here and then add them together. So the first thing is I'm looking at this 50 degrees, and I'd love to take tangent of 50, and I want to show you why. Tangent of 50 equals opposite over adjacent, which is that little piece that we want. So it equals to 85 over, and let's call this value a. So 85 over a. So to solve, now we're going to multiply both sides by a, and then simultaneously divide by tangent of 50. And to get that approximation, let's plug it into Desmos. And we get 71.3235. So that's now this section here. Now we need b. Okay, so I'm going to do a similar tactic with b. Instead, I'm going to use this 36. And again, looking at this nice right triangle, right? This has to be right if this is right. So I'm going to say tangent of 36 equals opposite over adjacent. So again, equals 85 over b. Now to solve, you kind of see the pattern, right? You multiply b over here while simultaneously kind of dividing by tan 36. So b equals 85 over tangent 36. Let's plug that into Desmos, see what we get. So here we get 116.9925. And now to get the total value of x, we're going to add these two together. But I'm going to actually add the unrounded values to get the most accurate answer here. So when we add these two values together, we get 188.3159. So x equals 188.3159. That's how you do it. Done. So for this one, I'm going to start by writing up SOHCAHTOA. And then next we need to find this value. So there's going to be a couple steps here. The first thing I'm going to do is I'm actually going to solve for this entire length here. So tangent of 26 for this larger triangle is equal to opposite over adjacent. We'll call the adjacent y. So tangent of 26 equals 119 opposite over adjacent, which is y. Then I'm going to multiply y to the other side. Y tangent 26 equals 119. Then we're going to divide both sides by tangent 26 like so. And that's going to be y, 119 over tangent 26. So we won't approximate yet in Desmos. We'll say that this is what y is. Now we need to get this little value here, because then if I can subtract that from y, I'm good to go. And I can find that again using tangent, because look, I've got 70 in this second right triangle. So I can say tangent of 70 equals opposite over adjacent, and I'll call that z. Opposite over z. And then I'm going to follow the same steps. Basically, z is going to equal, same thing, it's going to multiply here and then divide by tangent of 70. So we got 119 over tangent of 70. And now to get the x value, I do this minus this, right? Just as we mentioned, the big minus that little piece to get that remaining piece. So let's do that in Desmos now. And when you put it all in, you get 200.6737 when you round it there. So x equals 200.6737. Boom, done. So this says a radio tower is located 325 feet from a building. From a window in the building, so let's draw that building. A person determines that the angle of elevation to the top of the tower is 43 degrees. So here's my radio tower, right? And they're saying to the top of the building like so. We have an angle of elevation. That's this angle in here of 43 degrees. That's an angle from looking straight across to looking up, the angle formed there. And the angle of depression to the bottom of the tower, that would be coming down like this, is 31 degrees. That's again going straight out and then going down and then the angle formed in between. I'm going to kind of clean the drawing up and just make the tower this green thing here, okay? So basically what we're trying to do now is to find the height, find this green length here, okay? And the last little bit that we didn't put in was this 325, and that's this horizontal distance going across. So what you want to think about here is the ideal function that's going to somehow get you these values. And you could try sine, you could try cosine, but what you realize is those both involve the hypotenuse. We don't care about the hypotenuse. We care about the legs. We care about this leg, but we already know that leg. And then we care about these legs in each of these respective triangles. So when I take tangent, for example, of 43, it's equal to opposite over adjacent. So that's the top part, right? We'll call that x. So it's equal to x over adjacent, which is 325. Also, for the bottom part, if I call that y, I can set up another tangent. Tangent of 31 equals opposite over adjacent for the bottom triangle equals y over 325. So you can see that we can find x and y in both of these cases by multiplying 325 over. So x equals 325 tangent 43 and y equals 325 tangent 31. And then to get the full height, I just add these together. So we're going to do that in Desmos now. And we get 498.3471 for the height. And since this was given in feet, our answer is in feet. There's your answer. Boom, done. So this one says a 400 tall foot monument is located in the distance. So this is 400. From a window in a building, so we can say maybe here, a person determines that the angle of elevation to the top of the monument is 18. So that's like if I come straight out and look at this tall monument, right? The angle of elevation is this angle looking up. So the angle in here is 18 degrees. And then it says looking down to the bottom of this monument is an angle of 3 degrees. And now it says how far is the person from the monument. That's solving for this distance right here. So just so you can see, right, these are right angles, which makes both of these right triangles, and that's perfect for our trigonometric functions. And once again, I'm trying to use the knowledge that this is opposite and this is adjacent to know that, hey, that we need to use tangent, opposite and adjacent, okay? So now let's set up our two equations. But by the way, I need to make some sort of variable to represent this. So I'm going to call this lower side here. I'm going to call this x. Now I could call this top one y, but since I know the full length is 400, if that's x, this is just 400 minus x. And it's much better that we have a single variable. It's going to be much easier to solve. So first, I'm going to make my equation. I know that tangent of 18 equals opposite, which is 400 minus x, over adjacent, which this is what we're really trying to solve for, and we'll just call that y. Then I have, for the second triangle, I know that tangent of 3 degrees is equal to opposite, which is x, over adjacent again, which is y. So now we get a nice little system of equations, which means we can do a little substitution and solve for y. So if I look at this equation, if I multiply both sides by y, I can see that x equals y tangent 3. And now I can take this and I can plug it in for x over here. So now I've got tangent of 18 equals 400 minus, instead of x, I'm plugging in y tangent 3 over y. Now we got to somehow get the y's together and isolated so we can solve for y. So first I'm going to multiply both sides by y. So I get y tangent 18 equals 400 minus y tangent 3. And remember, tangent of 3 and tangent of 18, those are just numbers. I just haven't evaluated them. But I'm going to add them together because they both have y's. So then we've got y tangent of 18 plus y tangent of 3 equals 400. So now if I factor out the y, I've got y times tangent of 18 plus tangent of 3 equals 400. So the last step I'm going to do here is I'm going to divide both sides by tangent of 18 plus tangent of 3, right? So then I'm going to see what 400 divided by tangent of 18 plus tangent of 3 gives us in Desmos. So here we get 1060.09 rounded to the nearest hundredth. So the answer is 1060.09 feet. That's the distance to the monument. Boom, done. There's a lightning rod on the top of a building. From a location 500 feet from the base of the building, the angle of elevation to the top of the building is measured to be 36. From the same location, the angle of elevation to the top of the lightning rod is measured to be 38. Find the height of the lightning rod. So we need to draw this out. So we have a location here that's 500 feet from the base of the building. And they said that we've got two angles of elevation. We got going up to the top of the lightning rod, and then we also have going to the top of the building. And what they're saying is they're saying this angle here to the top of the building is 36. And then they're saying this entire angle to the lightning rod, it's 38. So this angle is 38, which means this little baby angle in here is just 2 degrees. So I'm going to write 2 so it doesn't get too confusing. So they want the height of the lightning rod, which is just this, which is x. And then we also have this entire height of the building plus everything. And maybe that we'll call y. And then we've got the height of just the building. We'll call that z. Okay. So if I can find y and I can find z and then just subtract, I should be good to go. So let's start with the appropriate function. Again, I don't really care about these hypotenuses. So sine and cosine probably aren't the right functions. Tangent makes a lot of sense. So start with tangent of 36. So tangent of 36 equals opposite over adjacent. So tangent of 36 equals z over 500. And to solve for z, we're just going to isolate by multiplying both sides by 500. So now I know that z equals 500 times tangent of 36. So now I need to just solve for y because then I can subtract z from y. Well, y, the entire angle here is 38. So let's again use tangent. Now we'll take tangent of 38 is equal to opposite over adjacent. So it's equal to y over 500. So I'm going to isolate by multiplying both sides by 500. So y equals 500 times tangent of 38. So now I have a value for y, I have a value for z. So these are the two values here. And as I mentioned before, if we just subtract z from y, we should get our answer. So let's do that in Desmos. And here when we subtract the two, we get 27.372 rounded to the nearest thousandth. So our answer is 27.372, and this measurement is in feet. There you go. Done. A 23-foot ladder leans against a building so that the angle between the ground and the ladder is 80 degrees. How high does the ladder reach up on the side of the building? So here's our building, and we're always going to assume, right, that that's a right angle. And here's the ladder kind of hanging like that, right? And they're saying the ladder is 23 feet, and the angle of elevation down here from the ground is 80. So now we got a nice little diagram here. And then it says, how high does the ladder reach up on the side of the building? Meaning, we're trying to figure out this length here, right? How high up it goes on the building. That's our x. So now, right, we're going to write out SOHCAHTOA, and we got to figure out the appropriate function. And I know 80. I know this is opposite. And then I also have the hypotenuse. Well, that tells me maybe we should use sine, right? Sine is equal to opposite over hypotenuse. So sine of that angle 80 is equal to opposite x over hypotenuse, which is 23. So to solve for x, now we multiply both sides by 23, and we get x equals 23 sine 80. Now let's plug it into Desmos and get the approximation. So here we get 22.6506. So since we're in feet, we get this answer in feet. 22.6506 feet is where it stands in terms of the height onto the building. There you go. The angle of elevation to the top of a building in Seattle is found to be 2 degrees from the ground at a distance of 2 miles from the base of the building. Using this information, find the height of the building. So here's our diagram. Here's that right angle. It's saying we're 2 miles away, right, over here, and we're trying to find the height of the building, and we know that this angle is 2 degrees. So now let's take this information and let's solve. By the way, in the answers, they found the height of the building in feet. So I'm going to convert miles to feet here. So 1 mile is 5,280. 2 miles is 10,560 feet. Now, I'm given an angle, I'm given a leg, and I'm trying to find another leg. And that's usually an indication that we need to use tangent, which is opposite over adjacent. No mention or use of the hypotenuse. So we got tangent of 2 equals opposite over adjacent, which is 10,560. Now to solve, we're going to isolate by multiplying both sides by 10,560. And let's plug that into Desmos to get our approximation. And we get 368.7633, 368.7633, and that's in feet. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.